Today we're going to look at 12.6, which is nonlinear systems. So nonlinear systems, unfortunately, cannot be done with the matrix stuff. So it'd be nice if they could, but they can't because they're not linear. Matrices are reserved for linear things. So what makes this nonlinear is that the second equation in this set has 2x squared in it. So this is where our skills, if we're going to solve it algebraically, substitution and elimination come back into play. So it's up to us to solve that one way or another. I like elimination. I think it's a good method. And here it looks like a pretty easy method to use because if I look at those y's, they're the same. All I've got to do to get it to eliminate is multiply the top equation by -1. And that's going to give me a -3x, a positive y, and a positive 2. And then I've got a system that I can solve by elimination. Now, the difference in this is that I'm going to have a nonlinear equation to solve. So the y's are still going to eliminate just like they did yesterday when we did the linear systems by elimination. But on the x's, x squared and x are not like terms, so they don't mash together into one thing. It ends up being 2x squared minus 3x equals 2. So we end up with this quadratic that we got to solve. Okay? So it's back to chapter 4 things here. So if we're going to solve a quadratic, what do we need to get the equation equal to? Yeah, that's right. Anytime we got an exponent on our variable and more variables, we got to get it equal to 0. So we're going to move the 2, and that's going to give me 2x squared minus 3x minus 2 equals 0. And then I have the options of solving by factoring or quadratic formula, whichever way I feel like doing. I'm going to do factoring on this one because that's my favorite way to do it, is by factoring. So I'm going to, what multiplies to be -4 and adds to be -3. And it's been a minute since we factored. So 2 times -2 is where the -4 came from. So front times back to get the top number. And then -3 is the b term there. So what multiplies to be -4 and adds to be -3? Yeah, -4, +1. Now, because it has the 2 in front of the x squared, I got to do the grouping step. So I'm going to group the first 2 together there, get the GCF is 2x. And then the second group, the GCF is a 1. And those parentheses match, so that means I did it right. So I have 2x plus 1 and x minus 2 are my factors. Then I'm going to take those two factors and I'm going to set them equal to 0 and get my solutions there. So 2x plus 1 equals 0, x minus 2 equals 0. So there's x equals -1/2. There's x equals 2. So we've got two x values. So that means when I go to work this and get my solutions, I should have 2 different y values as well. So I'm going to take those and I'm going to pick one of those equations to plug into. It doesn't matter which one, but I'm going to pick the easiest one, which would be the one that doesn't have the exponents in it, right? That's a lot easier, right? So I'm going to go to that one. And so when x is equal to 2, I'm going 3 times 2 minus y equals -2. That's going to be 6 minus y equals -2. Subtract 6. -y equals -8. And one last step, divide by -1. Y is +8. Okay. So there's one of my ordered pairs, 2, 8. So my ordered pairs, I'm just going to find a spot to put them. Put that. Ordered has ED on it. Ordered pairs. 2, 8. Got that. Now when x is equal to -1/2, I'm going to plug that in there. So that's 3 times -1/2 minus y equals -2. That's -3/2.
Good morning, Gabe.
All right, we'll pause.
Please rise for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please remain standing for a moment of silence. Thank you. You may now be seated. Have a wonderful day.
All right. All right, so we plugged that in. We multiplied 3 times -1/2 is -3/2. And we're going to move that over to the other side. Plus 3/2. And so that's negative y is equal to +1/2, because 3/2 is 1.5. If I'm adding that to a -2, that's a +1/2. And then last, divide by -1. Finish that up. Y is -1/2. Bless you. Bless you. All right, so there's my other ordered pair. -1/2, -1/2. All right. Nope, that should be a -1/2. That should be +1/2. That's a sign mistake there. So -1/2, +1/2. So there are my ordered pair solutions to that system that we solved by elimination. So a little bit lengthier work here, just because it doesn't work out to be nice little one-steppers to get one of your answers. And we can have more than one answer. So the picture of this, we could actually solve this by graphing if we wanted to graph these two. So let's look at that and see that that's an option as well. Graphing is always an option as long as both variables aren't squared. Okay? If both variables are squared, graphing gets a lot more complicated. Okay? So in this case, we got only that x is the thing that's squared, so this is going to be pretty easy to graph. If you had a y squared and an x squared, that gets a little bit more difficult to graph, because the way that your calculator has to have the information in order to graph it. So if I'm going to graph 3 minus y equals -2, what do I need to do to graph it with my calculator? I need to get what by itself? Y. So I'm going to move the 3x. So that's going to give me -y is equal to -3x minus 2. And then I'm going to divide by -1. And that's going to be y equals 3x plus 2. So I've got a line. And now to graph the -2 or the 2x squared minus y, I want to move the 2x squared over, get y by itself on it as well. So minus 2x squared. That's going to give me -y equals -2x squared. Technically plus 0, but we don't need that. And then divide by -1. So that's going to be y equals +2x squared. So what we're going to have here is a parabola that opens up and a line. And they're going to cross. So the parabola is going to get crossed by that line there. So I'm going to graph those two with my calculator. All right, so I got 3x plus 2, and then 2x squared. So here we have a parabola. The red one, that's our 2x squared, and the blue one is our 3x plus 2. Now I want to get the calculator to tell me where they're crossing. Okay, so second, trace, intersect. We've used this tool quite a bit in the last few weeks here. So first curve, just hit enter. Second curve, hit enter. Now here's where we got to move it on this one, because you got two places where they're crossing. You got one down here and one up there. So you want to move closest to the one you want at that moment. I'm closer to that one down there on the left, so I'm just going to move over there close to it and hit enter. It'll find the one your cursor is closest to. Okay? So move closer to the one you want. So here it says -1/2 and +1/2. That's what we found with the elimination that we did. Same answer. Okay? Now I want to get it to find that one up there that I think is 2/8. That's what I did with elimination, so it should be that. So I'm going to hit second trace again. 5. Enter for first curve, enter for second curve. On the guess, I got to move over there close to the one I want. And there it is, 2/8. Okay, so when I'm finding that intersection, I got to get y by itself on my graphs and on my equations so that I can get the graph to show up with my calculator. Then I'm using that intersect tool that we used a lot in chapter 6. All right. All right, so let's go to this one. So this one, you got a pretty simple equation up top, x plus y is equal to 3. And on the bottom, though, you got a pretty complex equation because it's got x squared and y squared. Okay? So I don't have any opposites on the x squared. I don't have any opposites on the y squared. I don't even have any y squareds in the first equation. So when I look at that, I think, okay, elimination is probably not my best choice here because it's not going to eliminate the y squared or x squared if I do anything. So this is where substitution would be a good idea. Now, when I look at that second equation, if I substitute in the place of x, I got to put it in 2 places. It's more work than I really want to do. So I'm going to substitute in the place of y. So I'm going to solve this equation for y so that I only have to plug that into one spot. So solving that for y, it's going to be y equals negative x plus 3. And I'm going to take that stuff and I'm going to put it in the place of y in that equation. So that's going to give me x squared minus 9x minus parentheses negative x plus 3 squared. So I'm substituting negative x plus 3 in the place of y, and I've got to square that. What's it mean to square negative x plus 3? It means take negative x plus 3 times negative x plus 3. Don't try to take a shortcut and just square the x and square the 3. That's not correct. Okay? It's going to be negative x times negative x. That's positive x squared. Negative 3x. Negative 3x. Positive 9. So in that spot, I've got a negative and then x squared minus 6x plus 9. Notice that I put what that binomial squared was in parentheses because this minus sign goes to all of that. Okay. So if I distribute that minus sign, I'm going to have x squared minus 9x minus x squared plus 6x minus 9. Now I can combine like terms. And this one really does well because what happens to my x squareds? Yeah, they're going to cancel each other out. One's a positive x squared, one's a negative x squared. That makes the solving way easier when those x squareds cancel out. Because now I don't have to factor. I just got to solve it for x. And now I'm going to put negative 9x and positive 6x together, which would be negative 3x minus 9 is equal to 3. So we got a regular equation to solve now. That's a lot better than having to factor. Negative 3x is equal to 12. So x is equal to negative 4. Which one of those equations would you want to plug into to find the y value? Yeah, that's way easier, right? Bottom one, you got squareds and plain x's and squared y's. I definitely would rather do the top there. So let's do that. Negative 4 plus y is equal to 3. So we're going to add 4. And y is just 7. So my ordered pair would be negative 4, 7. All right. So here on this one, algebra really is the best method. And I'm about to show you why graphing is not a great method for this one. And you can do it by graphing, but it gets pretty complex on that. So I'm going to show you why that's the case. So we use substitution there. So substitution and elimination are great methods for solving these nonlinear systems. Let's look at that as a graph. So if I want my calculator to graph it, what do I have to have by itself? Y. So the first equation, really easy to get y by itself, right? So we already did that once. We know it's y equals negative x plus 3. That's super easy to graph with the calculator. The second equation is the booger to graph with the calculator. Okay, so we're going to try to get y by itself. So I'm going to move the x squared. I'm going to move the 9x. So that's going to give me negative y squared is equal to negative x squared plus 9x plus 3. And I'm just putting in descending order out of habit there. Now, I got to get rid of this negative on the front of the y squared. So what do? Divide by that negative 1 that's there. That's y squared is equal to x squared minus 9x minus 3. Now, that isn't y by itself. That's y squared by itself. How do I undo a square? I take a square root. That's what makes this pretty complicated as far as graphing goes. And when I take a square root in the problem, I got to put the plus or minus in that. Okay, so that's going to give me y equals positive and negative square root of x squared minus 9x minus 3. So when I go to graph that, I've really got to graph 3 things, because your calculator doesn't have a plus minus button. It's got plus and it's got positive and it's got negative. So when I go to my calculator, I'm going to go and I'm going to graph. I'm going to clear out these others. I had negative x plus 3. That was the first one. That was the easy one. And then the second one is going to be the positive side of that square root. So I'm going to have a square root, and then I had x squared minus 9x plus 3. And then I had a negative side of that square root. So a negative, then the square root of x squared minus 9x plus 3. So color version helps with this because we can see, okay, the red one's going to be y2, the black one is y3. That's going to help us when we look at where they're crossing, because I don't know which one it crosses on. There's my line. That black one and red one together is the graph. They're crossing on the one up here. That's the positive side of that. That's the second one. So when I go to do my second intersect or second trace and intersect, first curve is going to be the line. Hit enter. Second curve, I got to make sure I'm on the piece that it's crossing. Okay, so I'm on that piece. And then for the guess, I'm going to move over here closer to where it's crossing. And there's negative 2, 5. Which is not what we got. Did I change the problem? Or did I type something in wrong? I better type something in wrong. No, I didn't.
It's supposed to be negative 3, right? On square roots.
Oh, yeah, it is. That's why. You're right. I did type something in wrong. It is a minus 3. Now we'll get it right. There we go. Now here's our line. Almost looks like the same graph. It's just shifted just a little bit out of that. Then second trace, intersect. First curve's the line, and then I got to make sure I'm on the second curve. So right now it's on the second curve, but it's not anywhere where it's got x values. So I have to look at the x values and make sure I'm getting over here to where these x values are, which is in the first quadrant, which would be negative x values. So second curve, make sure you're on the piece that it's crossing, hit enter, and then on the guess, just move closer. And there's the negative 4.7 that we should have got. A little bit more complicated on the graph when you're dealing with these non-linears. But graphing is still an option. It's just I'm faster at the algebra than I am the graphing, to be honest about it. All right, now let's look at one that's got a couple of fun things happening in it. It's got x squared and y squared in both of them. When I look at that problem, if it didn't have the squares on it, it would look a lot like what we did yesterday with the linear systems. But because it's got the squares on it, it's a little harder. But what method would work really good with this? Since they both have the same kind of variables. Well, I think elimination would really work great because I could eliminate x's by just making these a positive 6 and a negative 6. I could do the same thing with the y's. I can eliminate them by making one of them a positive 6, the other one a negative 6. So that's what I'm going to do. I'm going to eliminate y's and get x first. So I'm going to multiply this one by 3 and this one by 2. That's going to give me 6x squared. Nope, not 6. 9x squared, sorry. Can't multiply. 6y squared. 3 times 147. So that'd be 300 plus 120 is 420 plus 21, 441. And then the second one, I got 4x squared minus 6y squared equals negative 116. Now, when I add those two equations together, the y squareds are going to eliminate one another. And these two, they're like terms because they're the same x squareds. So that's 13x squared. And then whatever 441 minus 116 is. $325. Ooh, that's going to be nice. Okay. And now, how do I solve 13x squared equals 325? I need to get the x squared by itself, right? So I'm going to divide by 13. 325 divided by 13, does it go evenly? It does. Ooh, and it goes to a nice number there. I get x squared is equal to 25, and how do I solve that? Square root. Plus or minus the square root of 25. So I get two answers there. I get x equals positive 5 and x equals negative 5. Those are my two x values. So I'm going to work that out. And it really doesn't matter which one of those two you go into. They're both equally crappy as far as which one to plug into. I'm going to go to the first one because it doesn't have any negatives. That's my only reason we're going to it. So I'm going to plug in positive 5. So that's going to be 3 times positive 5 squared plus 2y squared equals 147. So that's 3 times 25, which would be 75. Now I'm going to get y by itself, or y squared by itself, so I can take a square root. That'd be 72 divided by 2. Ooh, that's going to be a nice number. That's going to give me... So it's going to be y squared is equal to 36. And I take the square roots. Plus or minus on the number side. So when x is positive 5, I get two y values. I get when x is 5, y is positive 6. When x is 5, y is negative 6. So I get ordered pairs 5, 6, 5, negative 6. When I plug in the negative 5, I'm going to use the same equation. Once I get here, you should realize something. This equation is exactly the same as that equation. The squared canceled out the negative part. So what are the solutions to this equation? Yeah, they're the same one. 6 equals plus or minus 6. So, or not y, y, not x, equals plus or minus 6. So I get ordered pairs negative 5, positive 6, and negative 5, negative 6. So this one had 4 places where it crossed. That's a lot more complicated than the linear. But the math is all math that we've done. All right, let's do one more. This one is probably as hard as they get because it has x squared, y squared, and plane x in it, and plane y. So this makes it pretty difficult out of that. So for this one, what I would do, anytime I have a plane variable out of that in there, and I don't have a matching plane variable with it, so like in this case, y is plane in the second equation, but I don't have a plane y in the second equation, I got y squared. I usually think about doing substitution there. That's the thinking that I use. Elimination wouldn't work here because I got this plane x, and eliminating x squared. Well, yeah, it could work because this is y squared. Y squared won't cancel out a y. X squared would cancel out an x squared, but this plain x over here leaves me an x and y's in the equation. I need one variable left. So the best way to do that on this one is to take that second equation and get y by itself. So the x squared plus 3x. And then I'm going to take that stuff and substitute it in for y in the other equation. And this is where this one gets to be a lot of fun. So squaring x squared minus, or x squared plus 3x, that's where it happens to be a lot of fun. And I still got the plus x squared out here. That's going to give me x to the 4th plus 3x cubed plus another 3x cubed plus 9x squared. Now I'm going to combine like terms. So the x squareds go together, the x cubes go together. All right, so we have a 4th degree polynomial to solve. So if I'm going to solve a polynomial, I need to get it equal to 0. Now, how do we solve a polynomial? Well, the first thing I'm going to do is graph it, see if it crosses at some nice places. I'm going to clear out this other stuff. So I have x to the 4th plus 6x to the third plus 10x squared minus 50. I see it crossing, but it's not at nice places. Now, there is a tool on my calculator that'll find me those numbers, though. I remember second trace. Which one of those will find me where it's crossing the x-axis? Zeros. That's an x-intercept. Now, it's going to ask me for a left bound, so that means I need to be to the left of where it's crossing. So here's where it's crossing. That's a little past -4. So I'm going to move my cursor over till my x says like -5, something. There we go. Then right bound, I'm going to move past that, hit enter. And I'm just going to hit enter again. There is my decimal for that zero, -4.30367. .30367. That's an x. I've got another x value there on my calculator over here in the first quadrant, or on the positive side of the x value between 1 and 2. I'm going to hit second trace, 0. I'm going to move over there. I'm just going to get close to 0 or close to +1. That's close enough. And then I'm going to move where my x is past +2. And then there it finds me that one, 1.5256439. Okay, those are my x values. I need to use that to find my y values. Okay, so I'm going to take those two answers and I'm going to plug them into one of those equations. It doesn't matter which, pick one. I'm going to go for the second one because it's got plain y. So all I got to do is, and I've actually got the second one where it says y equals. So all I got to do there is just plug these in for x squared and x, and it'll tell me what y is. So I'm taking that answer, -4.30 something 367 squared plus 3 times -4.30367. And that's going to give me the y value for that one, 5.61. So this one has a y equals, we'll go 2 decimal places on the final answer there. So 5.61. And then use that other one. Do the same stuff. Parentheses, 1.5256, I think. Yeah, 439. Squared plus 3, parentheses, 1.5256439. 6.90. So my ordered pairs -4.30, 5.61, 1.53, 6.90. Just going 2 decimal places for the final answers there. Notice I didn't round until I got to the final answer. So that one, that polynomial is tough because it doesn't break down with synthetic division because you don't have a whole number to use there, but it will work. You can use that 0 tool on the calculator. All right, so there's some practice problems out of the textbook, but again, I would probably focus more on the test review that I gave you yesterday. That's got, it's on 27 through, or 22 through 27 is the nonlinear stuff that you'll have to be able to do on the test. Okay, so make sure you're